pretty much with any statistical study you do, there's going to be some sort of table or graph to accompany it. Because when you have all sorts of data, it makes it a lot easier to look at if you consolidate it into some sort of picture, a graphic or a table or graph, or some way to represent it other than just like a list of numbers. So when we are starting to gather this data, there are two different types of data we can gather. We can gather qualitative data. This is data that describe qualities or categories. So qualities or categories. So, for example, like essay grades, because different teachers might score the same essay differently. So that could be like like your rubric, the 0, 1, 2, 3, or 4. Those would be qualitative because the numbers mean something. It's not like a grade. Well, it is a grade, but it's not quantity. It's a category. You just happen to have numbers in place for it. Okay, then you can also have quantitative. This is like a sound. These are quantities. So this is a count or a measurement. So if you have a number that's a count or a measurement, it's going to be quantitative. If it's not either of those, then it's going to be qualitative. So for example, scores, because it's a count of correct answers, or like your grade would be, a percentage of the total that you get right. So those are measurements. Another way you can think of it is if you can be like between any value between two things. Like for grades, it could be anywhere between 0 and 100. It could be 15.000003, right? So it could be anywhere in between, but qualitative is either one or the other. Now you might have descriptive stuff from it that could be differently, but like for rubrics, it can be 1, 2, 3, or 4, or 0, right? It can't be 1.5. It's going to be one of those. Okay, so let's look at some examples and decide if they're qualitative or quantitative. So, eye color of students in a class. Well, that's not a number at all, so that is definitely going to be qualitative. The responses of customers on a satisfaction survey that use a scale from 0 to terrible to 5 fantastic. So again, you're either going to select 0, 1, 2, 3, 4, or 5, nothing in between. So this is also going to be qualitative. Qualitative. Okay, home prices in a small town. So prices can be, anything at all, anywhere in between. So this one's going to be quantitative. It is a measure of the value of the house. Quantitative. Okay, daily snowfall in inches during January in Syracuse, New York. Again, you are measuring the snowfall, so this is also quantitative. The flavors of ice cream sold at a delicatessen. It's not a number at all, so this is qualitative. The flavor is going to be a quality of the ice cream. The breeds of all cats at an animal rescue shelter. So breed is a quality, so this is qualitative. Annual salaries of NBA baseball players. Well, this is going to be a count or a measure, right? Because you're measuring how much money they make. So this is quantitative. And the gold medal count of each team in the 2016 Olympics. And it is a count, so it is going to be a quantitative. Okay, now one way we can list all this information is by a frequency table. You use frequency tables with either quantitative or qualitative. If you're, we'll talk about those. So there's 3 basic columns in a frequency table. The first column is going to list all of your categories of each data. So if it's qualitative, then it's going to be like a list of all the categories. If it's quantitative, then you might have like a range, and we'll look at that here in a minute. So the second column is going to be the frequency of each category. Frequency means just the number of times that category appears in your data. So let's say it was like eye color in the class. The frequency could be like the number of blue eyes we have, or the number of green eyes we have in class. The third column, sorry, there's 4 columns in a frequency table. The third column is going to be your relative frequency. So we've used the term relative before with relative difference and relative increase or relative change. It's the same kind of thing. Relative just means it is in reference to something. So this is the frequency in a particular sample count. So it is going to be the frequency of that category over the total category. So it is a part over a whole. So this would be like the number of blue eyes in my class. Could be the number of blue eyes over the total number of people. And the fourth is going to be your cumulative frequency. This is the number of responses in a category and all preceding categories. So it's like your count so far. So let's say I have blue, green, hazel. Then if 3 occurred in blue, then I have 3. Then if 2 occurred in green, then I do 3 plus 2 is 5. And then add the rest on. So it's just like a running total. Kind of like your cumulative GPA is your GPA so far. Okay, let's look at a particular data set for examples. So a teacher makes the following list of grades she gave to her 30 students on the test. Construct a frequency table for the grades. Okay, so these are all the grades she has in her class. So let's count how many A's there are, and luckily they have them in order. So it makes it easy. So we have 1, 2, 3, 4, 5, 6 A's. We have 1, 2, 3, 4, 5, 6 B's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 C's. 1, 2, 3, 4, 5 D's, and 3 F's. Okay, so if we count up all these frequencies, so 6, 12, 22, 27, 30, that matches the number of students she has in her class, so that means we counted right. Okay, so relative frequencies. So we want to know the number of A's as a percentage of the class, so relative to the class. So we're going to have the number of A's divided by the total number. So that is going to give me 0.2, but we want frequency in percent. So that is 20%. So again, we have 6 B's over a total of 30 students. So again, we get 20%. Now we have 10 students that have a C. So 10 over 3 to get 0.3 repeated. So that is a 33%. There are 5 out of 30 D's. So that is a 0.16 repeated. So that comes to be about 17%. And then last we have 3 F's out of a total of 30 students. So that is a 0.1 or 10%. Now if we add all these up, we should get to 100. So we have 20, 40, 73, 90, 100, which is good. You could also add up all the decimals here and they should equal 1. But in my math lab, they're going to want the percentages. Okay, cumulative frequency. So it's what we have so far. So far when we counted A's, we had 6. And I suppose we could have done this in order, like as we went on. So B's, there's 6. So far what we've counted is 6 for A's, 6 for B's. So we have 12 total. So we've counted 12 students so far. Then we add our 10 C's to get 22 students. Then we can add our 5Ds. Get 27, and then add our 3Fs. Get 30. So then you just repeat the 30 down here. So we double check that this matches that, and it does, which is good. So what we can use this cumulative frequency for is, let's say I want to know, okay, how many students have at least a C in the class? Well, then you can just follow the C, and you say, okay, there's 22. And you don't actually have to add them up anymore because they're already added up for you. Okay, now let's talk about binning data, or making it into a range. This is often what we have to do when we deal with quantitative data, because the number of values is so wide, right? It can be, like for grades, it can be anywhere between 0 and 100. So you might not want to list out, 1, 2, 3, 4, 5, and then what do you do if it's 1.5, right? So what we're going to do is we're going to create categories of where we have a range of data. So for example, if you have income levels, it might be useful to create bins of 0 to 20,000, 20 to 40,000, and so on. So the frequency would be the number of people that match that group. So let's look at an example of that. Okay, so we're going to use 5-point bins, so 95 to 99, 90, 94, etc., to make a frequency table for a set of exam scores shown below. Include columns for relative frequency, cumulative frequency. Okay, so this time I'm going to use cumulative as I go to make it a little bit easier. Now this, we don't have to go all the way down to 0, because it looks like the smallest grade we have is a 60, which is good. So I just have to make 5-point bins down to 60. So I have 95 to 99, 90 to 94, 85 to 89, 80 to 84, 75 to 79, oops, I myself, 79, 70 to 74, 65 to 69, and 60 to 64. Okay, so now what I'm going to do is, well, there's a couple different ways to go about it. I like to make a tally. One way you can do is to make a tally. You can take it one by one and put it in the bin that we're supposed to go. So 89, you can put it in this bin. 77 would go in this one. 67 would go in this one. 88 would go here. 78 would go here. 98 here. 75, 90, 64, 92, 70, 68, 83, 86, 95, 79, 69, 60, 84, and 96. Okay, so that's one way. So you have 3, 2, 3, 2, 4, 1, 3, 2. Another way you can do it is by going bin to bin. So I can try to find all the ones from 95 to 99 and count as I go. And as I do that, I'm going to cross them off. So it makes it easier to find the other ones. So 95 to 99, I've got 1 here, 2, 3. 90 to 94, I have 1, 2, and that's it. 85 to 89, I have 1, 2, 3, and double checking they do match. I forgot. Okay, so if I do cumulative frequency as I go, I've counted 3 so far, and I count another 2, so that's 5. Now another 3, so I have 8. Okay, 80 to 84. I have 1, 2. So now I've counted 10. 75 to 79. I have 1, 2, 3, 4. So now I've counted 14. 70 to 74, I have 1. That's it. So now I've counted 15. 65 to 69, I have 1, 2, 3. So now I've counted 18. 60 to 64, I should have 2 left. 1, 2. So I've counted 20. 20 total here, which means there's 20 total here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. So we're good. Okay, so now we can do the relative frequency. So we have 3 in this bin out of a total of 20. So that is 15%. This is 2 out of 20. So it would be 0.15. This is 0.1, so this is a 10%. 3 out of 20 is again same thing here, so 15%. 2 out of 20 is the same as this one. 4 out of 20 is going to be 0.2, so that's 20%. 1 out of 20 is a 0.05, so that's 5%. 3 out of 20 we've already done is 15%. And 2 out of 20 we've also done is 10%. So we can count all these up. So we have 15, 25, 40, 50, 70, 75, 90, 100. So it looks like we did all that correctly. Okay, so that's a frequency table. Something else we might see is bar graphs and pie charts. So you should have seen these already in your past history with high school or another class. These are often used to display qualitative data, but they can also be used for quantitative. Okay, so a bar graph is going to use a set of bars to represent the frequency or relative frequency of each category. The higher frequency, the longer the bar. So it could be the actual number or it could be the percentage. Bars can either be vertical or horizontal, so you can have a graph like this, or you can have a graph like that. These are all bar graphs. Frequency is marked along the left axis. So if it's like this is your frequency here, and these are your categories. Otherwise, this is the frequency, and these are the categories. Okay, make sure you also have proper labels, otherwise it really doesn't mean anything. I mean, you can tell which one is longer than the other, maybe, if these are labeled, but otherwise, whatever. So these, the big thing to remember with bar graphs, though, is that the bars do not touch, because they're separate categories. It also, bar order doesn't matter. So in this case, you could, arrange them as tallest to largest, smallest to biggest, or you could put it in alphabetical order. Sometimes there's kind of a natural progression, but not always. So bar graph, it doesn't really matter what order you put them in, because they're different categories. A pie chart are used primarily for relative frequency, because if you think of it as different parts taking up a piece of the whole pie. So the entire pie would be 100%, and then each wedge is going to take up the same proportion as relative frequency. So these are going to be split up into different wedges. This will take up a certain percentage, this will take up a certain percentage, this will take up a certain percentage, and this one here too, and all of those percentages will be your relative frequency for each category that's in there. Oops. Okay. So example 4. We're going to look at a bar graph. Okay, so this is in case where you kind of have a natural progression, but again, it doesn't really matter. So bar graph shows the number of tickets sold each week by the Garden Club for their annual flower show. So in this case, it's an actual frequency, so the number of times something happens for each week. So part A, during which week was the greatest number of tickets sold? So the greatest number, of course, will have the largest bar amount, or largest bar height. So that is here, so that is week 4. Okay, during which week was the fewest number of tickets sold? Right, because this is frequency, you're going to want the shortest bar, in which case is this one, so it is week 2. Okay, how many tickets were sold during week 5? Okay, so we want to go to week 5, we want to know how many tickets, so we want the frequency. So we see the height, and that height is at 40, so they sold 40 tickets that week. Okay, so during which week were 40 tickets sold? We kind of already answered that one, but if you didn't know that, you go to the 40 tickets and you would see which bar graph ends at this line. In that case, it is week 5. Okay, part E, how many more tickets were sold during week 3 than week 6? Okay, so we're going to have to compare the frequency for week 3 and week 6. So the frequency for week 3, we go up and see the height, and this is at 30. Frequency for week 6 is about 19. We get the number more, we want to get the difference, so we take 30 minus 19 to get 11 tickets. So there's 11 more in week 3 than in week 6. Okay, how many tickets were sold in all? Okay, so in this case we have to find out how much was sold in each week. So in week 1, it looks like there's about 46 here. Week 2 looks to be about 11. Week 3 is 30. Week 4 up here, let's say, is 59. Week 5 said it was 40. And week 6 is about 19. Okay, so we're going to take 46 plus 11 plus 30 plus 59 plus 40 plus 19. Add all those up and we get 205 tickets in all 6 weeks. Okay, example 5. Okay, this time we're actually going to draw a bar graph. So here they're given us a frequency table here. So we have the entree and then the number of customers. And let's draw the bar graph for them. So we're going to put our categories on the bottom. So let's put grilled salmon here. And then we can put chicken salad here. Beef stew. Ham pie. Bacon burger. And cheese pizza. Okay, so grilled salmon, there's 350. So I want to figure out my range here on the side. These are going to be the number of customers. The lowest we have is 225. The highest we have is 450. So if this is 0, we can do 1, 2, 3, 4, 500 here. And that will get us all that we need. Okay, so grilled salmon was 350, so that is halfway between 300 and 400. I'm going to make my bar here. And you don't have to fill it in. I'm doing it just so you can see a little better. Chicken salad is at 400, so this goes all the way up to the line here. Okay, beef stew is at 300, so this goes up to the 300 line. Ham pie is 450, so that one goes up halfway between 400 and 500, which is about there. Bacon burgers, $3.75. So that is 3/4 of the way between 300 and 400. And then cheese pizza was $2.25. So just a quarter above 200. Okay, and there is my bar graph. Okay, now let's look at pie charts. Again, pie charts are relative frequency. So here we have black olives is 180, mushrooms is 150, onions is 70, and pepperoni is 390 for the number of people who have that as their favorite pizza topping. Okay, so what we need to do is figure out which one of these match. So we're given the number, we're given the frequency, but these are relative frequencies. So what we need to do is figure out the total by adding up 180 plus 150 plus 70 plus 390. And here my total is 790. So if I take these and I figure out the relative frequencies, then I would do 180 divided by 790, and I would get a 23%. If I did 150 divided by 790, I would get 19%. 70 over 790, 70 over 790 is 9%. And 390 over 790 is 49%. Okay, so now I just need to find the pie chart that matches these percentages. This first one, my pepperoni is 57%, so it's not that one. Here, my pepperoni is 390%, which should clue you in on this being wrong anyway, because this one, it should never be over 100%. Okay, so here we have 49 for pepperoni, which looks good. Onions is 9%, mushrooms 19, and black olives 23. So that one's it. This one, the black olives and onions are right, just the pepperoni and the mushrooms are a little bit off. Okay. So now let's use a pie chart to answer questions. So we have a survey of 7,505 vehicles on the campus of State University, yielded the following circle graph. Find the number of each vehicle that are on campus. Round your result to the nearest whole number. Okay, so they're giving us the relative frequency and the total. Remember, we found the relative frequency by taking the frequency and dividing it by the total, which means, so you have the frequency divided by the total equals your relative frequency. So what we can do is to figure out the frequency, we have to divide, or this is already divided, we have to get rid of this total so we can get the frequency by itself. So if we multiply both sides by the total, here we have divided by total, multiply total, so those cancel. So you're left with frequency is equal to the relative frequency times your total. You can also think of it as like your percentages. So right, this is a part out of a whole is a percentage. So you know the black olives is 23% of the total. So it would be 23% times the total. Okay, so motorcycles is 9% of the total. So you have 9% of 7,505. And you would get 675, rounded to the nearest whole number. Okay, so hatchbacks is 35% of the total. So you have 35% times 7,505. And you get 2627. So 2627 of the students had hatchbacks. Okay, pickups were 28%, so you do 28%, 0.28 times 7,505, and you get 2101. Sedans is 5%, so 0.05 times 7,505, and you get 375. Bands are 7%, 7505, and you get 525. And the convertibles are 16%, so 0.16 times 7505. And you get 1201. Okay, so if we wanted to check this, we could add up all these numbers. So 675 plus 2627 plus 2101 plus 375 plus 525 plus 1201. If we did that, we would end up with 7504. Does that mean I did something wrong? Well, in this case, we're only one person off, one vehicle off, which is probably due to rounding in all these. Remember, we were rounding each of these to the nearest whole number. Now, if we were able to add up all these exact numbers, then it would add up to 7504. Or 7505, sorry. But this is okay, just having one off. Okay. So then we can also use histograms and line charts. Now these are almost exactly the same. Just one looks like bars, and the other one is just a line. So a histogram is like a bar graph, but in this case they are going to be quantitative data. It's always going to be quantitative. And as such, the bars are going to they're going to touch each other. It's going to go in natural order, so the order does matter. The width of each bar represents the width of a bin, and this helps you see patterns with these measurements. And they touch because, as you're going from like 0, 10, 20, it's either going to be right in this one or this one. There's no like gap in between. So anyway, so they touch instead of being separate because of the categories. Okay, so a line chart is basically a histogram, but you're going to have dots at the top of the middle, which are going to be connected by lines instead of having the bars. They're basically exactly the same. Okay. These are often used, or especially line charts are often used with time to see how something changes over time, but not necessarily. Okay, so look at histogram. These are the scores of participant in a game from a total of 100 participants. So here we have the frequency, just the number, and then we have our scores down here. So if they score between 0 and 19, they're here. If they score between 20 and 39, they're here, and so on. So how many participants scored between 40 and 59? So 40 and 59 is this category here. So I look on the top, and it is at 25. So there are 25 people that scored between 40 and 59. Okay, how many participants scored fewer than 100? So we want anything under 100, so that's going to be any of all of these all together. Now there's a couple different ways we could do that. We could find out each one of these and add them up, or we could take the total minus the number in 100, the number who scored 100, right? So this would be a little bit easier. So the number who scored 100 looks like it's about 3. So we're going to say that's 3. So if all total it's 100, that means all 5 of these added together would be 97. Can't do math. Would be 97 participants. So only 3 scored 100, so everyone else scored below. Okay, how many more participants scored 60 to 79 than from 0 to 19? Okay, so from 60 to 79 is this category, so that is about like 37, 38, is that 38? Okay, 0 to 19, it looks like it's, well, I'm writing these as I found. So I found that was 25. This one I said was 38. And 0 to 19, we'll say is 6. So to find the difference, it would be 32. So 32 more participants scored in the 60 to 79 than they did from 0 to 19. Okay, so what is the ratio of participants who scored 60 to 79 to the total number of participants? So a ratio means usually a fraction. We're comparing two numbers together. So we want this to that, which means this is going to be the numerator. This is going to be the denominator. So 60 to 79 we said was 38. The total number of participants was 100, because they said that up here. So the ratio is 38 over 100, or 38%, or 0.38. So in my math lab, just watch how they ask it for you, or ask what they ask of you. So if they ask for a reduced fraction, you would take this and simplify it to small terms. If they ask for a percent, you'll put 38. If they ask for a decimal, you would put 0.38. Okay. So now let us draw our own histogram. We have scores for a basketball team. We're going to use this list to complete the frequency distribution table and then construct a histogram. So we can make a tally or count like we did before. I'm just going to well, I can do both just for practice sake. Okay, so 20 goes here, 31 goes here, 34, 21, 32, 42, 15, 30, 29, 23, 19, 23, 28, 32, 20. Okay, so you can have 2, 7, 5, 1. You could also cross it out like we did before, so 10 to 19 in the 10s. So I have 1, 2 here. And in the 20s, we have 1, 2, 3, 4, 5, 6, 7. 30s, we have 1, 2, 3, 4, 5. And 40s, we just have the 1. Okay, so 2, 7, 5, and 1. So let's say I have, we're starting at 10, so I'm just going to go ahead and start at 10 here, to 20, to 30, um, 50. Not going to be quite even, but I want to try to get all of these to be roughly even with each other. And then for frequency, we only have to go up to 7. So we'll just say 1, 2, 3, 4, 6, 7, 8. Okay, so between 10 and 19, there were 2. My first bar is here. Between 20 and 30, there were 7. So this is going to go all the way up to 7. And there's technically a bar up top. Okay, between 30 and 39, there was 5. And between 40 and 50, there was 1. And that is my histogram. So it's not too bad. Okay. Last example, we'll look at a line chart. So the following comparison line graph indicates the number of vehicles sold for a 7-week period by 2 different salespeople. Use the graph to answer the question. So the solid line, that's describing Pat's sales. And then the dotted line is going to be Chris's sales. So we're looking at two of them on the same graph. Okay, so this is the week, and then this is going to be the number of vehicles sold in that week. Okay, so A, in the 5th week, how many vehicles did Pat sell? So we look at the 5th week. Pat is my solid line. So I go to where my solid line is, and that is at 3. So he sold 3 vehicles. During what weeks did Pat sell more vehicles than Chris? So we want Chris to be more than Pat, which means Chris is going to be, Chris's line is going to be above Pat's line. So we want the dotted line to be above the solid. So in week 1, Chris is more than Pat. So that is week 1. Week 2, Chris is again more than Pat. Week 3, Chris is still more than Pat. Week 4, Chris still has more than Pat. Week 5, Pat has more than Chris. So week 6, Pat has more than Chris, and week 7, Pat has more than Chris. So it's just in those first 4 weeks. We'll probably see during what weeks did Pat sell more vehicles than Chris. What we said was 5, 6, and 7. Okay, how many more vehicles did Chris sell in the 2nd week than did Pat sell in the 2nd week? Okay, so the vehicles Chris sold in 2nd week. Week 2, Chris is the dotted line. Chris sold 5. How many did Pat sell in the 2nd week? Pat had, he was a solid line, so he had 3. So 5 minus 3 is 2. So Chris sold 2 more vehicles than Pat did in that 2nd week. Okay, during what week did Pat sell the fewest number of vehicles? So now we're only looking at this solid line, and it says what week did he sell the fewest numbers? The fewest numbers, right, will be the lowest point of it. Lowest point in the graph is right here, so that is week 3. Okay, during what week did Chris sell the fewest number of vehicles? So now we're looking at the dotted line. The lowest point on the dotted line is right here, so that is week 5. And what week did Pat sell the most number? So now we want the most, so we're going to have the highest point for Pat, who is the solid line. The highest point is here in week 7. During what week did Chris sell the most vehicles? So when did the dotted line have the highest? And that was here at week 1. Last question, how many more vehicles did Chris sell in the 1st week than did Pat sell in the 6th week? Okay, so Chris in the 1st week. So dotted line, 1st week, he sold 6. Pat in the 6th week, Pat is a dotted line, he had 5. So the difference here is just 1 more vehicle. Okay, and that's it for the section.